Let's take a look at this problem. It says find an expression for f of x in a status domain. F is a function that takes a real number x. So we're going to start with f of x equals x. And performs the following three steps in the order given. Subtract 13. So we take our previous transformation, which is just x, and subtract 13. Then take the square root. So we're going to take our previous transformation, which is x minus 13, and take the square root of it. And then make the quantity the denominator of a fraction with numerator 4. So put 4 in our numerator, and take this and put it in our denominator. And that would be our function. Now, to find the domain, we got two conditions. One of them is where the denominator is equal to 0. So if I set that equal to 0, this is what we cannot have, because if this is equal to 0, then we have division by 0. Now if I solve this, this is a radical equation. First step, get a radical by itself on one side, nothing in front of it, nothing after it. That's done. Second step, raise both sides to a power equal to the index. Index is whatever number's in the slot right here, and it's by default 2 if there's no number there. So we're going to take both sides of the second power. So we've got square root of x minus 13 squared is equal to 0 squared. Now the square root and the second power cancel each other, so we got x minus 13 and 0 squared is 0. Take negative 13 to the right side, so we're trying to get x by itself, and we got x equal to positive 13. Now this is one of the values we cannot have, because if we put 13 in our original function, we have 13 minus 13, which is 0. Square root of 0 is 0, and you cannot have division by 0. So x cannot equal to 13. Now keep that in mind. We're then going to look at the radical with an even index. When you have a radical with an even index, you cannot have a negative number inside it. So what we do is we take what's underneath the radical, which is x minus 13, and we set it greater than or equal to 0. It's always the same. When you got a radical with an even index, you always find your domain, you always set it greater than or equal to 0. Then we want to solve for x. So here I'll take negative 13 to the right side. It becomes a positive 13. Now this, if I were to write it in interval notation, would be a bracket on 13 and it's going to positive infinity. Bracket on 13 because there's a line underneath. Whenever there's a line underneath, you put a bracket. Infinities always have parentheses. But we just said over here that x cannot equal to 13, which means I have to change this to put a parentheses on 13 to say that it does not include the 13 since x cannot equal to it. And this would be our domain.